All right. So this is the first question in this tutorial. This is the first question saying, given that x and y are disjoint sets, simplify x complement union y complement. So when you talk of or when you talk about disjoint sets, we're simply talking about sets that have no intersection. Sets that have no intersection. What do I mean? Let me just draw something here. Okay. Yeah, so if for instance I have this this Venn diagram, I would draw two sets there, x and y. So you can see this is my x and then this is my y. So you have two sets there. So if we're talking about two disjoint sets, meaning they have no intersection. So when you look at these two sets here, they are disjoint. So now let us try to solve this one here, which is saying simplify x complement union y complement. So in other words, this x complement union y complement can also be written as x intersection y. Then you put everything in brackets, and then there you put your complement. Some of you might be asking yourselves, why have we changed the sign here on the middle? You should understand, or rather, you should just go back to your notes on De Morgan's laws. You'll find this principle there. Whenever you are distributing the complement or you are factoring out the complement, you have to change the sign there on the middle. So this is what we're trying to talk about here. So the question is saying simplify this part here. So we're saying these two sets are disjoint. X and Y are disjoint sets. And then we said if two sets are disjoint, meaning they have no intersection. So X intersection Y is simply an empty set since the sets are disjoint. And then what is the empty set complement? So these are just simple steps for solving that question. Yeah, so the last step here is this one. So I'm saying what is the complement of an empty set? It's simply the universal set. So this is how you simplify such a question. It's just as simple as this. All right. So let us now proceed. Let us look at B. Let's look at B. So B here is saying, given that P and Q are any two sets, express the following in its simple form. So on this one, I will not solve all the questions. Looking at time, we don't have much time. I know some of you are tired, you are from work, you want to sleep, you want to rest. So I'll solve maybe 2 or 3 questions from here, and then I'll leave some as an exercise which you are going to do during the weekend, and then make sure that you submit it before Monday. I'll also add some other questions. So they're saying, given that P and Q are any two sets, express each of the following in its simple form. So I'll start with this same one here. This one is saying P complement intersection U, and then P union. So I'm going to write my P complement there, or maybe you just pardon me. Let me just be using an apostrophe as the complement instead of me writing C. So I'll be using this as a complement. So P complement intersection, then we distribute the complement here. It's going to be, let us open our brackets. We're going to have P complement. Remember what I said, when you're distributing the complement opening the brackets, the sign here will always change. So we're going to have Q complement as well, like that. So here what's next now? We distribute the P intersection. So say P intersection P, we write it here. We're using distributive law. P intersection P, they all have complements. And then you write this symbol here. I'll write it there. Let me just write this properly. So I'll write that symbol there, and then I'll open another set of brackets. This P intersection, now you distribute it in the brackets, combine it with Q complement there. So I'm saying P complement, and then say intersection Q complement, like that. So what is P complement intersection P complement? So we're trying to find P complement intersection P complement. I think this set cannot be simplified further than this. Yeah, because you still go back to the same one. Still go back to this. Yeah. So I'm going to have P intersection. You still go back to the same one. So this is what you're going to have. Yeah. So this was going to be simplified further if this intersection was union. Yeah, it would have made sense. Well, it would have made more sense than this. All right. So let's move to the next question. We have this one here. So here we were distributing. Now in this case, we're not distributing, but we're using distributive law now in the opposite direction. So we can see, in short, we're trying to factor out now. We're going to factorize. You can see what is common here. There's P intersection. There's also P intersection there. So I'm going to write my P intersection outside. Okay. And then I'll open this set of brackets there. Then I'll write this Q here. When I remove P intersection here, I'm going to remain with Q. And then I write that union. And then here, when I remove the P intersection, I'll remain with Q complement. Okay. So let me write my P intersection there. Then, oh, sorry. This is P. And then I'll write my intersection there. So we have Q union Q complement. So Q union Q complement is just the same as if I have a set here. This is set Q. So Q, it is what is inside there. Then when I combine it with Q complement is something which is just outside there. So when I combine Q plus Q complement, I'm going to have the all universal set. I can either use E or U, it's still the same. So P intersection E will still remain P. So this is how you simplify the second question there. Let's proceed. Let me do even the third one here. This one there. So for this one, but this one is straightforward because what you're just required to do here is to distribute the complement. This complement, when you distribute it to everything there in the brackets, you're going to have P, instead of having P complement, you just have P there. And then the sign there will change to be union, complement to cancel, meaning I'm going to remain with Q there. This is the simple form of this question. Yeah, let us now do the last part here. I thought I'll not manage to finish them, but let me just say something on this one. So on this one, what you do is you first have, if you want, you can first deal with what is in the brackets there. And then after dealing with what is in the brackets, that's when you come and distribute the complement. Yeah, so what am I trying to say? This is what I'm trying to say here. So I'm going to say P intersection Q, and then you put them in brackets like that, and then union, and then you have P there. Remember what I said about this slash. This slash is the difference of two sets. It can either be represented by a minus or this slash. So the difference of a set can also be written as that one set intersection the other set, in this case, which is Q. So it's going to be P intersection Q complement, and then we close the brackets like that. Remember, there are square brackets outside. We have square brackets outside with a complement like that. So here we can see that there is P intersection, which is common there. So we can factorize it. Yeah. So we're going to have P intersection, and then you open brackets, you're going to have Q union. You get this one there, you put it there. Union Q complement there, like that. But remember, there are square brackets outside with a complement like that. So this is going to be P intersection Q union Q complement. Remember what we said? We said it's a universal set. So this is what you're going to have. Then you have your complement outside there. So P intersection universal set, you still get P, and then remember there's a complement outside there. So I'm going to have something like this. All right, I think we're done with this question. Let's proceed and see what we have. Yeah, so here is another question in set builder notation. Yeah. So let me just talk about this n here. Remember what we said, this n means the number of elements in any given set. In other books, they say the cardinality of a set. Cardinality is just the number of elements. And then you can see this P here. This P is just a symbol of a power set. So in other words, when they say find the NPC, they are simply telling you to say find the cardinality of the power set of C, meaning the number of subsets of C. Yeah, it's just as simple as that. Then here, it's just a matter of on this question, it's just a matter of you analyzing the set builder notations there. You convert them to roster form, to roster notation. So our A there would be, our A there is equal to, our A there is equal to, they're telling us to say X is a member of integers, and then these integers are all less than 5. These integers are all less than 5. Oh, sorry, not less, but greater than 5. So these integers are all greater than 5. So we're going to write the integers which are greater than 5. So we have 6, we have 7, we have 8, and it goes on like that. You put 3 dots. So B is equal to, X is a member of integers, but these integers are greater than 9. So meaning we're going to start with 10 and then going up. We're going to start with 10, then you write 11, write 12, and then you go on like that. Then let us now also write our C. Our C is just equal to, they're saying these are integers between 5, here that was supposed to be X. These are integers between 5 and 7, including 5 and 7. So meaning we start with 5, we go to 6, and we have 7. So apart from that, I mean, after doing that, you now just have to find the what the intersection. I mean, the questions that have been asked. For instance, here we've been told to find A intersection B. So A intersection B, you simply look at the common elements between A and B. There you can write them. They're straightforward. B union C, you just combine B and C. There you go. It's simple as that. A union C complement, meaning you find the union set, you combine A and C, and then see the what? Yeah. See the complement of that set is what you're going to write. Same applies to this. This one you first have to simplify it. This one has first to be simplified, and then you find the solution. Finding the cardinality of the power set of C. We said our C is equal to we said is 5, 6, and 7. So now to find the cardinality of this power set, you're going to write it as n. It's given by this formula. Actually, the cardinality of any given power set has a formula. So it's going to be P, and then you have open brackets, you have C like this. Then it's given just by a simple formula, which is 2n, 2 to the power n. So this n represents the number of elements in the set. So here we have 3 elements, which implies that we're going to have 2 to the power 3, which gives us 8. So when you list the subsets that this set C has, you discover that they are all going to be 8 in total, including C itself and the empty set. Don't forget about the empty set and C itself. They are all part of the subset. All right, let's now see our next question. Yeah, so this is the question that has been giving hell to most people. Yeah, it has really given a lot of people problems. So what we're going to do, I'll spend most of my time here explaining how to solve these questions. It's just bad that some people have not attended, though there are a lot of people that paid for these sessions. They don't want to attend. Anyway, they are going to watch the recorded video. But this is the part that I'm going to spend most of my time on, because these we revise them, and also these we revise them. So I'm not going to waste time on these others. Let me just explain this part. Sorry, this one here. So I'm going to spend much of my time here. Yeah. So the question is saying, let x be equal to 0 and 10 inclusive. B, the universal set. So meaning x is our universal set here, and then A is ranging from 1 to 4, and then 1 and 4 inclusive there. Then B is ranging from 2 to 8, and 2 and 8 there are not included. They are not part of the set B. C, when you see these kinds of brackets there, note to say note to say where this kind of bracket here is, that number which is close to it is not included into this in the set. It's not part of the set. And then when you look at C here, you can see that there are 2 kinds of brackets there. We have this one, which is the square brackets, and then these normal brackets. Yeah, they have a very good name which I can't pronounce here. So you have these square brackets, this simply means that 3 is part of this set C, and then 6 is not part of set C. And then they are telling us to say all these sets A, B, and C are all subsets of X. This statement here should not confuse you. When they tell you they are subsets of sets, meaning they are just within this range from 0 to 10. Yeah. For each of the following, actually, the question is saying find each of the following, and display them on the real line. So we're going to be first finding the solution, and then we display it on the real line. Yeah, I think that is the simplest way we can approach such kind of questions. Let us now start with B complement. So I know to say my universal set is denoted by X, which is equal to, or which is ranging from 0 to 10. 0 and 10 inclusive, meaning 0 and 10 are part of this universal set. And then they are telling us to say we find B complement. So I'll first start by writing my B here. B is equal to what? B is equal to 2,8. So 2,8. Yeah, so when you look at this 2,8, you first have to ask yourself, is this 2 and 8 part of the set B? And when you look at the kind of brackets that have been used there, you can agree with me that 2 and 8 are not part of the set. So we're just remaining with 10 minutes, but I'm sure you're going to give me maybe 20 minutes. I just want to explain a lot of things about this. So I'm going to make another link. I'm going to form another link, and then I'll send it to the group. Let me just see if I'll manage to be done within these remaining minutes. If I won't, then I'll form another link. So B is equal to 2,8. And then we know to say that 2 and 8 are not part of set B. Since the kinds of brackets that have been used there, they are open brackets, they are not closed brackets. All right. So if we are to find B complement, they are saying all these sets are subsets of X, and then X is the universal set, meaning we don't have to work beyond or outside the universal set, meaning the lowest number that we have on these numbers is 0. So if we are to find B complement, we know to say 0 is not part of this set, meaning 0 will be part of B complement. Since 0 is not part of B, meaning 0 will be part of B complement. And then I'll write comma there now. And then when you're getting the lowest number there, get the bracket which is there. So this is the reason why I've gotten the closed brackets or the square bracket there. So you say B complement is equal to, you open the brackets there with a square bracket, and then comma. And then I'm going to write this same 2 here. I'll write it there. Now, which kinds of brackets am I going to put at the end of this 2? Look at these brackets here. These brackets are telling us to say 2 is not part of, they're telling us to say 2 is not part of B, meaning 2 is part of set B complement. So if 2 is part of B complement, it means that we're going to use these kinds of brackets to show that this 2 is part of B complement. And then apart from that, we're going to also, we have not finished. We also have to find the numbers which are above 8 but below 10. Above 8 but below 10. So how do we do that? We're going to combine the two sets with the union symbol there. And then we'll say, is 8 part of set B? No. If it's not part of set B, it simply means that it's part of B complement. So what do? We open these kinds of brackets, and then we write our 8 there. And then after writing your 8 there, you write comma, then you write 10 there, because that is the highest number that we have, and then get that same bracket which is there. So this is our B complement. But the question goes further to tell us to do what? To draw these on the real line. How do you do that? So the way you draw this question on the real line is you can write your real number like that. I mean your number line like that. Oh, sorry, this is supposed to be a. It's supposed to be an arrow. And then even this side there's an arrow. And then so I'll not write all the numbers here. Let me just write the required numbers. But for you, you have to write them. You have to count from 0 to 10. Anyway, let me just write them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll also add one there, 11, I think even 12. So I'm going to have my negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If I want, I can also include 11. Anyway, let's just work within the what the given. Let's just work within the given interval here, which is the universal set. So now, how do you show this on the number on the real line? So you start from 0 there. Is 0 closed or open? It's closed. So I'm going to write a circle there, and then it's going to be shaded to show that it's what? Show that it's closed. And then from there up to where? Up to 2. 2 is also closed. And then like that. And from there, I'm going to also start from where? From 8 up to 10. From 8 to 10 will also be like that. And then what I'll do is I'll also add the universal set on top there. Just to tell them to say, I have the universal. So this is the universal set. And then when you look at it, it is closed on both ends. So there are a lot of ways in which you can show these sets on the real line. This is just one way, and this the one that I've seen to be the simplest. So you also make sure that you label them. This is the universal set X. Then this one is B complement. We also have this one to be our B complement. So it's just as simple as that. Let us now try to do what? To solve for A intersection B. And then I'll solve A intersection B and also probably even the last one there. Yeah. Anyway, if you can understand just A intersection B, these other ones, it's just a matter of you simplifying them before you find the final answer. So let me just do A intersection B as well. So I'll not delete the real line there for future use. Okay. All right. So A intersection B. A intersection B. So I know to say my A is ranging from 1 to 4, and then B is ranging from 2 to 8. So how do I find my A intersection B? Meaning, how do I know the common elements in A, which are both in A and in B? And what you should understand, you guys, is that when you are dealing with intervals, not to say uh, the universal set, or not the universal set, rather. Uh, yeah, if you have not been given the universal set, not to say you are dealing with real numbers. And every time you are doing what you are using intervals, you deal with real numbers. That's how it is. You don't deal with natural numbers or whole numbers. You deal with all numbers in total, meaning there are also squares, decimal points, and everything, fractions. Yeah. So we can start with. Let me now. Yeah, we can start finding the second part here. We're saying A intersection B. So how do you know, or how do you identify the common elements between A and B? It is simple. First of all, you can see, you can check, do we have 1 in A? Is there. Do we have 1 in B? It's not there. So we move on to the other small number. Do we have 2 in A? Yes, it's there. Do we have 2 in B? Yes, it's there, but it's not part of the set. So in short, my A intersection B is going to be like this. Uh, you look at first here in A, do we have 1? Yes, 1 is there in A. Do we have 1 in B? We don't have. So you leave it. You move on to the next one, to the next smaller number. Do we have 2 in A? No. Do we have 2 in B? Yes, it's there, but it's not part of the set. This is the reason why I wrote these two. But since it's not part of set B, I'll also not include it in the intersection. So I'll use these kinds of brackets. Then I'll write my comma there, and then I proceed. Where do I now end? You look at another smaller number. Which number is small between 4 and 8? 4 is small. Let's now check. Do we have 4 in A? Yes, it's there. Do we have 4 in B? Yes, 4 is between 2 and 8. So we're going to write this 4. But which kinds of brackets are we going to use? You check if it's found in both in A and B, then you use this one. And when you look at A here, we have 4 there because we're using the square brackets on 4. And then when you look at B, 4 is between 2 and 8, meaning these are the correct brackets to use. So this is A intersection B. Yeah, so this is our A intersection B. Then now you go on the number line there. You go on the number line, you show it out. So we're going to have a circle there on 2. We also have a circle on 4. Then you write a line like that. Ah, anyway, it's I don't know this wave where it's coming from. So this is what we're going to have. So we're going to have this. Hey, I don't know where this wave is coming from. Anyway, let's just proceed. So this is the line that we're going to have here. And then you look at the brackets there. Where am I going to shade and where am I not supposed to shade? While there's a square bracket there, you shade. So this is how you show it. So you even write A. This one is going to be, it's going to help us to write A intersection B. Yeah, so this is my A intersection B. And of course, don't forget to add the universal set. If you have been given the universal set, don't forget to write it. Don't forget to draw it on the number line as well. So this is your X. All right. So let's proceed. Um, let's see how you can solve let's see how you can solve these other questions. So we have A intersection B complement. So this one is having a complement in this other. So if you have complement like that, so if it has a complement, forget about these two. Yeah, forget about that too. Because it's failing to be deleted, so just forget about it. Or let me do this. Now this will mean that I'll delete everything anyway. Let's, for the sake of people's understanding. Yeah, so we're saying A intersection B, and then we have a complement. Okay, we have a complement there. How do you find this? A intersection B. Remember what we found? We found our A intersection B to be equal to what? A intersection B is just what we are just from finding here. And it was, let me just write it here. Oh, sorry, A intersection B. We found A intersection B to be we found A intersection B to be equal to 2 comma 4. It was like this. So now what is going to be our complement? So our complement, remember we've been given this universal set. So meaning our complement will start with the lowest number in the universal set, which is 0. And we'll end with the first number here in the A intersection B, which is 2. But is 2 part of the complement or part of, is 2 part of the complement or part of A intersection B? It's part of the complement since it's not in A intersection B. So meaning we're going to use the square brackets here. And then you combine the two sets with union. And then you look at 4 there. 4, is it part of A intersection B? Yes, meaning it's not going to be part of the complement. So write our 4 there. Then you come to the last number of the in the universal set there, which is 10. So you write your 10 like that. Then of course, the brackets of the universal set, you get them the way they are. So this is my A intersection B complement. And then drawing it on the number line, it's just as the same as we draw B complement. So I'll just draw this number line in advance. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 11, 12, 13. So I have 0, 1. Can also put a negative here since we have the universal set. 2, we have 3, we have 4, there's 5, there's 6, 7, 8, 9, 10. You have 11, and then lastly you have 12, like that. So you now just have to put in this. We have 0 to 2. So 0 there is shaded. And then 2 there is also shaded. You write it like that. You come to this other part. You have 4 is open. And then 10 is shaded. Yes, something like that. Okay. Then here it's just a matter of drawing a line. Of course, don't forget to put your uh, your universal set like that. Since the universal set is shaded on both ends, you make sure that you shade it on both ends. Yeah, so this is it. This is how you find A intersection B complement. Just as simple as that. Okay? Let us now, let us now look at this one here. A intersection B slash C. So when you talk about this slash, it's just a set difference there. So we're going to have A intersection. So instead of writing a slash there, I can write B intersection C complement. Yeah, I can write B intersection C complement. Still the same. So how do you now solve such a question? Remember what I said when we were just beginning these sets. I said sets are also part of mathematics, and every rule that is in mathematics applies also on sets. Where addition is concerned, you add. Where multiplication is concerned, you multiply. So these are this is also mathematics. So in this, so the reason why I brought in this statement is because, as you can see here, you can't just start solving this question from nowhere, just start boom. No, you first have to use what we call body mass, meaning you have to start with what is in the brackets. So you first have to find B intersection C complement. The final answer that you're going to have, you intersect it with A. You find the common elements between B intersection C complement and then A. And then the final answer that you're going to find is the one that you're going to draw on the real line. Just as simple as that. So I'm going to add this one as part of your work, even this one, and I need the work as early as possible. Yeah, those that may manage to finish tomorrow, please do so. Yeah, I want to mark this work. I want to know whether you've understood, you've gotten something from this. And it's good for you guys who are online and you've managed to watch it live, because I know sometimes when you're watching it just using YouTube, you'll be limited. You will not be able to ask questions. Yeah, so right now what I'm going to say is those that have questions, you can ask on sets and everything that we have covered today. Yeah, and even something that maybe we covered some time back, then you didn't understand, you can ask. Uh, you can ask. Waiting for questions. You can ask. Okay, I'm waiting for questions. So I'm going to send a simple exercise that I will need that will need to be answered before Monday. Yeah, I just want to check whether you've understood or not. Seems like people do not have questions here. Yeah, so silence is also loud. Silence also means something in short, in other words. Yeah. So I've gotten something from your silence. You have told me that you have understood. All right. So see you on Monday. But I'm going to send a question. I'm sorry, I'm going to send questions based on these same sets. All right.